Okay guys, let's have a look at this one. Number 9 then, y equals 2x cubed. Let's find the turning points then. Let's find dividing x, which should be fairly straightforward, shouldn't it? 6x squared. Let that equal 0. When does that equal 0? Well, that equals 0 when 6x squared is 0. Divide by 6 both sides. X squared is 0, yeah, and that means that x will be 0 when you square root both sides. You get 0. Okay, so let's get that's the input. What's the output? So it's just one turning point. X equals 0, then y equals 2 lots of x cubed. The x value is 0, so it's 2 times 0 cubed, which is 0. So y is 0. Yeah, there's our turning point. Let's get the second derivative. d2y by dx squared is equal to, right, differentiate 6x squared, you get 12x. And if you put the value x equals 0 in, you're going to get 12 times 0, which is 0, which is neither positive nor negative, yeah? So we can't say, because of the sign of the thing, that it's, so this is 0. So we cannot say if it's a max or min simply by this. Okay, so we're going to have to, so this is, we're uncertain, aren't we, whether it's a max or min because this is 0. So what we've got to do then is we're going to have to look either side. Here we are, 6x squared, yeah? So the point is, when x is, if we draw our sketch then, here it is here, here's x, here's y, here's 0, and we know when input, we know that basically, now we don't know what happens here. Right, I've drawn it two possibilities, but that's not all that can happen. All we know here is that dy dx is 0. We don't know if it's a max or min. We don't know if it's anything else. Okay? But what we can do now is just look at the gradient function. What can we say about the gradient function? Something squared, 6 times something squared, it's always what? Whatever input value you put in here, it's always positive, yeah? Other than that x is 0. That's the only time when the gradient function is 0. So it's always going to be positive. So if you think about it, positive slope is a hill. Alright? So you've got a positive hill. So basically, and then when x is negative, you've still got a positive hill, haven't you? So you're traversing a positive hill that basically comes down to here, and that's the only time when it flattens out, and then it remains to be a positive hill. Can you see that? So I'm just going to draw it in, because we're just gaining experience in drawing sketches. This isn't a dedicated curve sketching section, but it's almost ancillary to that, isn't it? So you've got your positive hill, haven't you? Comes out, flattens out here. It's the only place when dy dx is 0. And then it must go back down, mustn't it? Because you've got a positive hill again, so to speak, when you're looking at it. Yeah? Because you're visualizing this by facing forwards as if this were a hill, facing the positive direction. There you are. And you see a positive hill because the dy dx is always positive for any input values of x. For example, if you put -1 in here, if you're here, and that was -1 input, you're going to get 6 as an output, aren't you? So that slope there at the tangent at -1 is 6, really steep slope. And similarly, if you put 1 in here, you'll see that again, the slope of that hill there on the tangent is 6 at 1. So can you see that? And can you see as you get closer to 0 on either side, say here, if you put something smaller in, this will be really small times 6. It'll be small. It'll start to flatten out. So can you see how that curve is generated then, can't you? Yeah? So that's just a brief little description. This thing here is called a point of inflection. It's the other thing that can happen. If it's not max or min, then we can have a point of inflection, typically speaking. So there we are. Let's put that in. That's what that is. It's when it snakes back, in a sense, on itself. Here at this point of inflection, it just so happens we've said that's a turning point as well, because we're looking at the turning points, aren't we? Alright, so that's when it twists back on itself, a curve does. And it just so happens that this is also a turning point, because that's what we were looking for. We let dy dx equal 0 when we found that x was 0. Yeah? So let's go to the graph then. Without further ado, dragging that out. And let's put in our function, shall we? So what we want to put in? We want to put in 2 times x cubed. 2 times x cubed, yeah? Let's enter that. There we are, there's the curve. Again, if you want to be fussy, you could say, oh, I'll have a closer look at that. So let's go -3, say, to, but you can see how steep it gets either side to 3. Yeah, and there we are. You can see what's happening, can't you? It's always positive. It flattens out here, then twists back on itself, so to speak, snakes back on itself, and it twists up there. That's y equals 2x cubed. Yeah? Okay, good. That's that one done then. Let's go on to the next question. Good.